All right, welcome. Today, we're diving into one of the most mind-bending ideas in all of physics, the heterotic string. This thing, it's a single object that might just be the blueprint for our entire universe. So, to get us started, I want you to chew on this really weird question. What if a fundamental string wasn't stuck in just one version of reality? What if the vibrations zipping one way down the string saw a totally different number of dimensions than the vibrations zipping the other way? It sounds like something out of science fiction, I know, but that's the wild idea at the very core of this whole explainer. And don't worry, we've got a plan. We'll kick things off with the big quest that got us here in the first place. Then we'll meet the strange hybrid string, figure out how it juggles its dimensions, see the two incredible solutions that pop out of the math, and finally, discover how a whole universe might be hiding inside of it. So why would anyone even bother dreaming up something so complicated? Well, it all goes back to the holy grail of physics, finding a single, beautiful theory of everything. You know, one theory that unites gravity with all the quantum forces and describes every single particle with one elegant set of rules. That's the grand quest. But man, that path is tough. Early stabs at string theory, as cool as they were just full of problems. Some of them predicted these totally bizarre faster-than-light particles called tachyons, which would just break causality. You know, the whole cause comes before effect thing. Others were just a mess of mathematical contradictions that made them complete non-starters. Physics was stuck. And the breakthrough that got it unstuck was the heterotic string. Now, that name, heterotic, comes from a word in biology, heterosis, which basically means hybrid vigor. It's when you combine two different parents and get an offspring that's way better than either one. And that's exactly what the string is, a clever, powerful hybrid of two older ideas. Okay, so here's where it gets really wild. How does this hybrid work? Picture waves traveling along this string. The waves that are moving to the left, they act like they're in a 26-dimensional universe, based on an older, simpler idea called the bosonic string. But the waves moving to the right act like they're in a 10-dimensional universe, which is based on the more advanced superstring theory. And this is so important because the superstring side includes fermions, you know, the building blocks of matter, electrons, quarks, all that stuff. It's one string with a serious split personality. And this isn't just a loose analogy. The great physicist Joseph Polchinski put it perfectly. The theory is a literal fusion, a heterosis of these two earlier ideas. It grabs the best bits from both and smashes them together to create something totally new, something that might actually work. But it leaves us with one heck of a question. How on earth can one single object deal with a 26-dimensional world and a 10-dimensional world at the same time? I mean, it sounds like a flat-out contradiction. But physics has this brilliant trick up its sleeve. And the answer is this thing called compactification. Here's a way to think about it. Imagine a garden hose. If you look at it from really far away, it just looks like a one-dimensional line. But if you get up close, you see it has a second dimension, right? A little circle you can go around. String theory says the extra dimensions of space-time are just like that. They're curled up into a tiny, microscopic shape that's just too small for us to see. In this case, a shape like a torus, basically a donut. The solution is just so elegant. Both the left movers and the right movers travel through the same 10 big space-time dimensions that we know and love from superstring theory. But what about those 16 extra dimensions that only the left movers feel? They get compactified. They're all curled up into this tiny internal shape that only the left-moving vibrations can see. And just like that, you've solved the mismatch, and you've got a consistent 10-dimensional theory from our point of view. So after all those mathematical gymnastics, building a hybrid string, curling up its dimensions, you have to ask, what was the payoff? Well, when the dust settled, something truly incredible happened. The theory didn't just work, it worked beautifully, and it solved the huge problems that its predecessors couldn't. The first major win, remember those pesky faster-than-light particles, the tachyons, that just wrecked the earlier theories? The heterotic string gets rid of them. The math just cleans itself up. And as you can see from the source text here, the final theory is tachyon-free. That's a huge victory for making a theory that actually makes sense. But it gets even better than that. You see, the demand that the theory has to stay mathematically consistent through all this is incredibly tough. It's like a mathematical straitjacket. You can't just curl up those 16 extra dimensions any which way you want. It turns out the laws of physics only allow for two, and only two, specific ways to do it. This isn't a theory with a million different outcomes. It's a theory that points to a very specific answer. So this is the really crucial point. This whole complicated setup doesn't give you endless possibilities. Nope, it narrows everything down to just two unique, consistent theories. They're named using the language of group theory, which is all about symmetry, and they're called the SO32 heterotic string and the E8X-E8 heterotic string. Just two magic answers, handed to us by the math.
And it's that second one, the E8X8 string, that led to one of the most jaw-dropping discoveries in physics. Because it turns out that this purely mathematical thing, born from this weird hybrid idea, seemed to know something unbelievably deep about our actual real-world universe. Now, E8 is just the name for a big, complex mathematical pattern, a symmetry group. What physicists found is that this big E8 structure can actually break down into smaller, simpler patterns inside of it. Kind of like how a complex musical chord is really made of a few simpler individual notes. And if you look at this table on the slide, you can actually see some of the ways it can break down.
And here it is. This is the big reveal. Tucked away inside the structure of one of those E8 groups, physicists found the exact mathematical symmetries that run every single known particle and force in our universe. The symmetries of the standard model of particle physics were just sitting there, waiting inside the vibrations of this string. It's unbelievable. I mean, just look at this table from the source. This string of symbols here, SU3 cross SU2 cross U1, that might look like gibberish, but that is the mathematical engine of the standard model. It describes the strong force, the weak force, and electromagnetism. And the E8X-E8 heterotic string just spits it out, naturally. It falls right out of the theory. That's just a stunning result. Just let that sink in for a second. What this quote is saying is that it's not just the forces, but the actual particles of matter, the quarks and electrons that make you, me, and everything else, can all emerge from this one unified E8 structure. The whole zoo of fundamental particles could just be different notes being played on this one fantastically bizarre hybrid string.
And that leaves us with a truly profound final thought. The heterotic string, it started as just a clever trick to fix some math problems, but it ended up accidentally describing something that looks an awful lot like our own universe. So you have to wonder, is the incredible complexity of everything we see, everything we are, just one particular song, one specific vibration, playing out on a single string that's living in two different dimensions at the same time?